Imagine a place in space, not too hot, not too cold, but just right. A place where oceans can shimmer, rivers can flow, and life can take its first breath. Astronomers call this the Goldilocks Zone, and it may be the single most important key to finding life beyond Earth. But what exactly is this zone, and how does it change around different stars? From dim red dwarfs to blazing blue giants, the Goldilocks Zone shifts dramatically. Tonight, we'll travel across the cosmos and explore where alien worlds might hide, and which stars give life the best chance to thrive. Just right. The term Goldilocks Zone comes from the old fairy tale of Goldilocks and the three bears. In the story, Goldilocks searches for porridge that isn't too hot or too cold. It has to be just right. In astronomy, this analogy works perfectly. Planets too close to their star become infernos like Venus, too far away, and they freeze like Mars. But in the middle, in the sweet spot, lies the possibility of liquid water, and with it, the potential for life. Scientists define this region by distance in astronomical units, or AUs, the space between Earth and the Sun. For our Sun, a G-type star, the Goldilocks Zone stretches roughly from 0.95 to 1.4 astronomical units, and Earth, it sits almost exactly at 1 astronomical unit, comfortably in the middle. That's no coincidence. Without this placement, we wouldn't be here to ask these questions at all. MTP stars, the red dwarfs. Now, let's shrink things down. The most common stars in our galaxy aren't big like the Sun. They're small, faint, and red, so-called M-type red dwarfs. They make up nearly 70% of all stars in the Milky Way, because they're so dim. Their habitable zones lie incredibly close, between 0.03 and 0.3. Oh, that means a planet would have to orbit much closer to its star than Mercury does to the Sun. One famous example is Proxima Centauri b, orbiting our nearest stellar neighbor just 4.2 light-years away. On paper, it's inside the habitable zone, but red dwarfs flare violently, blasting nearby planets with radiation, and being so close means most of these worlds are tidally locked, one side in eternal day, the other in permanent night. Could life survive there? Maybe. If an atmosphere or ocean could spread the heat, alien microbes might still call these worlds home. K-type stars, the orange dwarfs. If red dwarfs are too unstable, what about their bigger siblings, the K-type orange dwarfs? These stars are slightly smaller and cooler than the Sun, but much more stable than red dwarfs. Their habitable zones stretch from 0.3 to 0.8 astronomical units. And here's the exciting part. K-type stars can live for 20 to 40 billion years, 2 to 4 times longer than the Sun. That's an enormous window for life to evolve. Astronomers sometimes call these stars Goldilocks stars themselves because their planets may offer the best balance of stability and longevity. One promising world is Kepler-4, to be located about 1,200 light-years away, with nearly Earth-like conditions and orbiting inside the habitable zone of an orange dwarf. It's considered one of the most potentially habitable exoplanets discovered so far. G-type stars. Our familiar Sun. Next comes the familiar G-type yellow dwarfs, like our Sun. Their habitable zones range from 0.95 to 1.4 astronomical units. Earth, of course, sits almost perfectly in the middle. But G-type stars aren't the most common, and they don't live forever. The Sun is about halfway through its 10 billion year lifespan. That may sound long, but compared to K-type stars, it's relatively short. Our existence is proof that K-type stars can support life. But the question is whether civilizations around such stars have enough time to emerge, thrive, and survive. As our Sun ages, its habitable zone will drift outward. In a billion years, Earth may be too hot for life as we know it, even before the Sun becomes a red giant. So while G-type stars are our baseline, they may not actually be the most promising hosts for long-term life in the universe. F-type stars, brighter, shorter lives. Stepping up in size, we reach the F-type stars. Brighter and hotter than the Sun, their habitable zones sit farther out, between 1.5 and 2.2 astronomical units. Imagine Earth's orbit pushed nearly to Mars. These stars glow beautifully, but they burn their fuel faster, lasting only 2 to 4 billion years. That might sound like plenty of time, but on cosmic scales, it's short. Complex life on Earth took nearly 4 billion years to emerge. Around F-type stars, evolution may run out of time before it can produce civilizations. A and B-type stars. Giants of the sky. Now let's turn to the luminous giants, the A-type and B-type stars. Their brilliance means their Goldilocks zones lie far from the star. For A-type stars, the sweet spot stretches from 8 to 12 astronomical units, comparable to Saturn's distance from our Sun. For B-type stars, the habitable zone could be dozens or even hundreds of OA away. But here's the catch: these stars live fast and die young. A-type stars survive only about 1 billion years, while B-type stars may last just a few million. That's barely enough time for simple microbes to evolve, let alone civilizations. While they dominate the night sky with their blue brilliance, they're poor candidates for nurturing life. In short, the bigger and bluer the star, the less chance for alien neighbors. Which stars are best? So where should we look for life? M-type stars are abundant, but dangerous. G-types like the Sun work, but time is limited. F, A and B-types burn too fast. That leaves the quiet, long-lived K-type orange dwarfs. Many astronomers believe these are the true homes of alien life. With billions of years of stability and wide habitable zones, K-type stars may be the universe's best incubators for biology and intelligence. Conclusion: the Goldilocks Zone reminds us how delicate life really is. Our existence depends on a narrow band around a single star, at a precise distance, in a fleeting moment of cosmic time. And yet, scattered across the galaxy, there are billions of other zones, billions of chances for oceans, forests, and civilizations to bloom. When we point our telescopes at distant stars, we're not just looking for planets. We're asking the oldest question of all: are we alone? The Goldilocks Zone is where the answer may be waiting, just right, somewhere in the stars.